So, I am Shyamala, Assistant Professor from Department of Chemistry. Today I am going to give a lecture on chemical kinetics. I am going to touch only the basis of chemical kinetics. Okay. So, what do you mean by chemical kinetics? You know, it is one of the branches of physical chemistry. It deals about studying the rate of chemical reaction and the mechanism of chemical reaction. So, chemical kinetics is nothing but studying the rate of chemical reaction and that mechanism. The rate of chemical reaction and the mechanism of chemical reaction. So, it is just a contrast to the thermodynamics, because you know the thermodynamics will tell us about the feasibility of the chemical reaction. So, thermodynamics means it tells about the feasibility of the chemical reaction, it not tells about the rate of chemical reaction. So, chemical kinetics, it not only concerns with the studying the rate of chemical reaction, it also tells about the factors which are affecting the rate of chemical reaction. So, what are the factors affecting the rate of chemical reaction? So, shortly we can say chemical kinetics is composed of three things. So, one is how the reaction take place, how fast or slow the chemical reaction take place, and what are the factors affecting the rate of chemical reaction. So, the answer for these three questions will tell about the chemical kinetics. How reaction happen, how fast the reaction happen, how fast or slow the chemical reaction happen, and then what are the factors influencing the rate of chemical reaction. What are the factors influencing the rate of chemical reaction? So, just we go to the next one. What is the rate? We are telling about the chemical kinetics means it is studying about the rate of chemical reaction. So, before to know about the rate of chemical reaction, you should know what is a chemical reaction. So, usually what happens in a chemical reaction? So, generally the reactant is converted into a product. Okay, so RT stands for reactant, so PDT stands for a product. So, during a chemical reaction, one substance is converted into another substance at certain condition. At certain condition, in a given time, the reactant is converted into a product. Okay, so to understand the reaction, it is important to know the rate of a chemical reaction. So, first I said it is a chemical reaction. To understand the chemical reaction, it is important to know the rate of a chemical reaction. It is important to know the rate of the reaction. How fast or slow the chemical reaction take place. It should be useful in our day-to-day life. Okay, let's see how to express the rate of the chemical reaction. So, rate of chemical reaction. The rate of chemical reaction is expressed as R minus dA divided by dt, that is equal to plus dP divided by dt. This is the rate of the reaction. For the reaction, A gives P or PDT. PDT stands for product and A is the reactant. Consider this is a reaction. For this reaction, the rate of the reaction is expressed as R is equal to minus dA divided by dt, that is equal to plus dP divided by dt. So, what is this minus dA divided by dt? I already said A stands for reactant. Okay, during the reactions what happened? The concentration of the reactant starts to decreases. So, this negative signs indicate the decrease in concentration of the reactant, and during the reaction the concentration of the product starts to increases, and this plus sign indicate the increase in concentration of the product. So, the rate of the reaction can be expressed in two forms. One is decrease in concentration of the reactant and increase in concentration of the product. So, rate of, whenever you write the rate of the reaction, that is R is equal to minus dA divided by dt plus dP divided by dt. So followed by this rate of chemical reaction, you can write the rate equation or for this reaction. You can write the rate equation. So what is this rate equation? So rate equation, it relates rate of the reaction with concentration of the reactant. It relates rate of chemical reaction with concentration of the reactant. CONC stands for concentration, RT stands for reactant. You already know what is the rate of the reaction, how it is expressed. So rate of the reaction is expressed as R and concentration of the reactant is taken as the A. Okay. So for this reaction, you can write the rate equation as R is directly proportional to A. To remove this proportionality constant, we are introducing the constant called as the rate constant. So R is equal to K into concentration of A. Clear? So R stands for rate of the reaction and this one is the concentration of the reactant. The rate of the reaction is directly proportional to the concentration. The proportionality is removed by introducing the constant called rate constant. K is nothing but rate constant. So rate constant is temperature dependent and it should be determined experimentally. It is temperature dependent and it is determined experimentally. Okay, followed by this rate equation, you should know what is order and then molecularity. Okay, so first we discussed about what is the rate of a chemical reaction. The rate of chemical reaction may be defined as the change in concentration of the reactant or product with respect to the time. So I said decrease in concentration. Specifically, if you want to express the rate of the reaction, mean the change in concentration of the reactant, that is it decreases, the concentration of the product is increases. And then rate equation, which relates the rate of the chemical reaction with the concentration of the reactant. Order is nothing but sum of power of concentration of the reactant in rate equation. Sum of power of concentration of reactant in rate equation of that particular reaction. Of that particular reaction is called order of the reaction. So RXN mean reaction. Okay. For this reaction, I wrote this rate equation is R is equal to K into concentration of A. Here, what is the power of the concentration of the reactant? This one is a concentration of the reactant. The power on the concentration of the reactant is considered as a 1. So the order of the reaction is taken as the 1. Order for this reaction is taken as 1. So instead of this A, one more reactant is added, mean it become A plus B. So A plus B gives product. Similarly, the rate equation can be expressed as minus dA divided by dt and then minus dB divided by dt. In former case, we use only the one reactant. In later case, we use the two reactant. So two reactant mean same. Instead of this, again you have to express another reactant, minus dB divided by dt, that is equal to dP plus dP divided by dt. The rate equation is changed as K into concentration of A and then concentration of B. K into concentration of A and then concentration of B. For this reaction, the order is taken as the 2. Because the power on concentration of the reactant is taken as 1, here taken as 1. So 1 plus 1 is equal to 2. So I already gave the definition for this order, the sum of power of concentration of reactant in the rate equation. This is the rate equation. In rate equation, the power on the concentration of the reactant is 2. 1 plus 1. Sum means addition. So 1 plus 1, it is 2. Okay. So order for the second reaction is the 2. Okay. So in not all cases, you can determine the order by the rate equation. Mostly, the order determination is done by many methods. 4 methods are there. One is the off-life method, graphical method, Van-Hoff differential method, initial rate method. So these are the most commonly used methods for the determination of order. Graphical, Van-Hoff differential method. Okay. So, in the chemical kinetics, these are the basic terms. We should know what is the rate of chemical reaction, how it is expressed, and what is rate law, rate equation, and then order, and then molecularity. So, I gave the methods how to determine the order, off-life method, initial rate method, graphical method, bond of differential methods. So, followed by this order, you have molecularity. What is molecularity? The number of molecules, as the name itself indicate, it indicates the molecule number. So, number of molecules or ion present in rate determining step. Present in rate determining step is called as the molecularity. Okay. So, what is rate determining step? For example, if we have a multi-step reaction, that is A gives B, B gives C, and then C gives a product mean, not all the steps are, or not the rate of the reaction in all the steps will not be equal. In some cases it may be fast, in some cases it may be slow, in some cases it may be very fast. Okay. So, in determining the rate of the reaction, you should know the slow step. So, which one is the slow step? That slow step will give the rate determining step. For molecularity determination, you should know the slow step, that is rate determining step, and you have to count the number of molecules or ion present in that step.